Okay, now since we talked about the conceptual design, let's move to the technical design. Technical design build on conceptual designs and requirements by taking high-level ideas and turning them into concrete technical details that explain exactly how the solution will work in reality. In conceptual design, we outline the software's main components, how they connect to each other, and what responsibilities each part owns, without worrying yet about low-level implementation. Technical design takes this understanding to the next stage by clearly explaining how each responsibility will actually be fulfilled using technology, structure, and interaction. A technical design is not complete until every component is refined enough that a developer can understand it clearly and confidently build it without guessing. To make this possible, technical design breaks large components into smaller, well-defined parts that are detailed enough to be implemented correctly and consistently. Alright, let's talk more about the technical design. This is the stage where software stops being an idea and starts becoming something you can actually build. In technical design, our job is very simple to say but hard to do well. We take big components like large pieces of the system and we keep breaking them down into smaller and smaller parts. And why do we do this? Because big things are vague, small things are clear. Each smaller part must have one clear responsibility, not two, not five. When component has single responsibility, it becomes easier to understand, easier to design, and easier to test, and easier to change later. So we keep breaking things down until there is no guessing left, until a developer can look at a component and say, yes, I know exactly what I need to build. That's when technical design is doing its job. Now at this level, words and sketches are no longer enough. Conceptual mockups are great for ideas. They help us answer what are we building. But technical design must answer a deeper question. How exactly will this work? That's why we use technical diagrams. Diagrams remove ambiguity. They force clarity. They show what components exist, how they are connected, who talks to whom, and who owns which responsibility. If something cannot be drawn clearly, it is usually not understood clearly. These diagrams also serve another important purpose. They are shared language. If somebody want to know about the system, so you can show the diagrams, and if he is a technical person, he would understand the technical design. When multiple developers work on the same system, diagrams help everyone see the same picture, not their own interpretation. They show both structure, how the system is organized, and the behavior, how data and actions flow through it. So this coordination is critical. Without it, teams build pieces that technically work but do not work well together. So technical design is not about creating documents. It is about eliminating uncertainty before coding begins. When done right, coding becomes execution, not exploration. And that is the mindset of true software architect. Thank you so much for watching this. Before you go, please don't forget to subscribe to my YouTube channel and turn on the notification bell so you never miss any of my upcoming videos. I regularly share valuable lessons, practical tips, and step-by-step tutorials to help you improve and grow. And if you are serious about mastering software design and architecture and want a complete structured learning experience, so I have created a full course that includes detailed lessons, assignments, quizzes, and downloadable workbooks to help you practice and apply what you learn. So if that sounds helpful, just check the link in the description below and enroll in the course today. I would love to see you inside and support you on your learning journey.